I remember the kid, but I don't remember him. Yeah, I remember now. Yeah, you'd always be like,
All right, so the average rate of change. One of the questions on there, guys, is asking to take and view between, let's say, A to D. Okay, if I'm interested in finding the average rate of change, they're going to walk you through the couple of things, a couple of steps that you need to find the average rate of change. So they're not going to say, right off the bat, what is the average rate of change? They're going to ask you a couple things first. And then you're going to take those couple things that you find and piece them together. Okay, so our average rate of change formula is this. It says f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. Okay? If you remember, that is the same exact thing. The same exact thing as, okay, so this is a y value, right? It's the y value that's paired with which x? Is it paired with x1 or x2?
X2.
X2. So this here is the same thing as y2. This is a y value. What's it getting paired with? Y1, right? And we got x2 minus x1. What is this? Slope. So what is this? Slope. Okay? That's all we're doing here. Okay? So if I want the average rate of change from A to D, okay, all I'm doing is finding the slope of that red line. Okay? Now, if I want to find the slope of that red line, the first thing is to find the difference in the y values, right? The difference in the y values. Well, if I say f of 4 minus f of negative 4. So 4 would be this x value here. Negative 4 is that x value. So f of 4 is what amount? 6. Minus f of negative 4. Negative 6. That gives me 12. That number right there from Algebra 1 is called the net change. Okay? Net change, and the way I remember what net means is that I get a pay stub every 2 weeks, and on it says my gross income, and then underneath it, it gives me a smaller number, a much smaller number, and it says net income. Okay? And net income, it's smaller, meaning that things were deducted from it. My insurance, my retirement, my vision, all that kind of stuff. All those things get deducted out of my gross income. Okay? So my gross income is kind of what I sign up for when I sign my contract. So this is how much money we're going to pay you. Net income is actually the amount of money that I get to take home. But it reminds me, net income, I take that home, that's what goes in the bank. That's different than what I started with, what my gross income was. There's a change there. Does that make sense? Something was subtracted. So that's the idea here. Something was subtracted. Okay? Net change. We're talking about the change from this y value to that y value. It's kind of the overall change between the y values. Okay? On the entire domain that we're interested in. So we're interested between negative 4 and positive 4. Okay? Now, if I want to find the average rate of change, the average rate of change, think about this. If I'm going from A to D, let's say that down here I'm in a valley. Okay, maybe I'm hiking, and up here is a mountain, right? Okay? As I get there, the average change in elevation is 12 whatevers. Okay? Does that make sense? Okay? Well, as I walk, am I always walking at that rate? Am I always changing the same amount as I walk from A to D? Or would you agree that maybe in these first 2 miles, that rate there is different than the next 2 miles. You agree with that? Okay. First 2 miles, I'm not walking as a steep rate as I am in the second 2 miles, right? And then the same thing here, so that and that are different. Okay. So the individual change between successive X values is going to be different, but overall, on average, aren't we going from an X value of -4 to +4? So that's an 8, maybe an 8-mile gap or something like that. So on average, I'm increasing maybe 12/8 for every mile. Does that make sense, everybody? So that's the average rate of change, and that's your slope. That's the exact same thing as the slope of A to D. Okay? So when they ask you, because those questions are saying, here's a picture. They're asking like what f of 6 is and f of 3. So they're asking what your y values are. Okay? And then they ask you next, what's the net change? Well, that means I just take those y values and subtract them. Okay? My thought is that when you're looking at your graph, because some of them are maybe like this, and they get these 2 points there, that net change, I want to know whether it's positive or negative. Okay? So it makes sense to whatever that x value there is, that you take f of x2 minus f of x1, right? Always subtract the furthest to the right minus the one to the left of it. Does that make sense? So make sure you keep that order. Now, in regards to doing the slope, it doesn't matter. Because if I subtract those of x2 minus x1, f of x2 minus f of x1, then the bottom is going to be x2 minus x1, and the sign will be, it'll work its way out. Okay? If I flip-flop those and go f of x1 minus f of x2, and I divide by x1 minus x2, the signs will work themselves out, right? We've seen that if the slope is going to be negative, then the order is either going to put the negative sign in the numerator or in the denominator, and it'll just work its way out, okay? But if I'm just finding net change, I want to know if that change is a decrease or an increase, so it makes sense to go subtract the point furthest to the right minus the point to the left. Does that kind of make sense? Okay. Are there any other questions on that we were maybe confused about? Maybe it's just some vocabulary there. And that's the thing, and I know maybe it's a bad assumption to ask you to remember back to maybe 8th grade for some of us, 9th grade for some of us, okay? Some of us 8th grade twice, Chuck. But the idea of how math courses work, and I'm just trying to get you guys to pick up on this, because as you get to like a traditional college class, this is college class, but you get to a traditional college class, they're going to expect that you know your high school math. They're going to expect that you know every piece of information from prerequisites. So when they come across something like net change, they're not going to explain what it is because you saw it previously in another course. Does that make sense? And I think that's a shell shock for a lot of people, okay? Because they're like, well, in high school I was trained that if I didn't know something, somebody would tell me, okay? It ain't that way in college, okay? So just kind of remember that idea. Now, the question was posed last period, okay? So I'm not saying this to anybody in here, but you know, if I didn't know what net change was, if I'm on a website and it brings up this phrase net change, do I know I'm talking about functions? Yeah. Can I just go to Google, type in net change of functions? Yeah. Or what is net change? Maybe I just type in net change, average rate of change. All one word, one phrase, okay? And just see what populates and click on something and start reading, okay? That's the research that you're going to have to be able to do when you are getting stuck or confused about something, especially at the next level. That being said, I want to talk a little bit. We started to do this yesterday, but I want to talk about these even and odd functions. Okay, we had two rules yesterday that we ended with. First one said if f of x equals f of negative x, then your function f of x is even. Good. Which even meant that we had this symmetry. The second rule said if f of negative x equals the opposite of f of x, then f of x is odd. Which means we have origin symmetry, a couple different ways. We'll talk about this. You can have, maybe call it a reflection about the origin. If you remember back to geometry, it's a rotation of 180 degrees about the origin. There's a lot of different ways that we can phrase this. We call it x-axis and y-axis symmetry. Okay, so I'm just going to kind of generate real quick this image here. Okay, and I don't know, looking at this, I think this is going to be kind of a nice, let's see if we can, that's going to be a nice function to kind of mess around with. In determining whether something is even or odd. And the odd part is what is usually the most difficult thing, okay, to be able to recognize whether something is odd or not. I'm going to take f of x. So I'm going to say if x is greater than 0, let's graph f of x. So I'm just trying to get it to highlight. That's kind of the code that we have to use just to highlight the part of the graph that is in the right half plane of the xy axis. Okay. If this thing has origin symmetry, there's a couple different ways we can think about this. The most kind of, I think, elementary way, which is still a pretty complex idea, is that we're going to take this blue portion, we're going to reflect it across the y-axis. And then once I reflect it across the y-axis, I'm going to reflect it across the x-axis. And what happens there is we get the other branch of the curve. Does that make sense? So the way I'm highlighting that is that we did an x-axis followed by a y-axis, or a y-axis followed by an x-axis reflection. And it shows up, it lands on top of the curve. Does that make sense? Okay. So visually, what I always ask myself is, if I were to take this graph, so I start with this graph now, even or is it odd? Well, if I fold on the y-axis, nothing lands on top of one another, right? Okay. So it's not even. But if I follow it up by folding on the x-axis, all parts that were on the left overlap all parts that are on the right, so then it's going to be odd. Does that make sense? Okay. Another way of thinking about it is doing a rotation. So if I take that portion, I'm going to rotate it around the origin. Let's go make this slider M, and we need that to go between 0 and 180. All right, so now as I take that blue portion and I start rotating it around the origin, if I get to 180 degrees and it lands on top of the rest of the curve, then that tells me I have origin symmetry. Does that make sense? Or rotational symmetry, 180 degree rotational symmetry. Okay? What that means to us. Okay, look at point D. Point D is 4, 6, right? 4, 6. What's point A? -4, -6. Let's think about this. Give you that point right there. Point E is 6.97, 3.35. I'm going to rotate point E real quick. Rotate point E around the origin. I get E prime. How do E and E prime relate to one another? If E prime is the x's and y's of E, right? Okay? If that is happening, if your ordered pairs, okay, if you know the function is odd, you should be able to take any ordered pair and negate the x and the y, and that new ordered pair also shows up on your function. Okay? That's something we talked about 2 years ago when we did transformation. You guys remember doing reflections? I gave you a triangle and I asked you, okay, translate this, move it left, right, up, down. And then I asked you to reflect it. And I gave you these rules here. Okay? Well, let's think about these rules real quick. If we look at this one here, think about an x-axis reflection. If I have this point here of 2, 4, and I fold on the x-axis, isn't that going to go down here?
Yeah.
To 2, negative. Haven't we talked about when we did transformations yesterday that if there was a negative out in front, it negates the y value and flips the y value over the x-axis? That is analogous to what that rule told us in geometry. You're going to, every ordered pair that you have, you negate the y, and that effectively flips it over the x-axis. Okay? Well, this says, well, if I'm going to flip over the y-axis, I'll flip over the y-axis, that point 2, 4 is going to become negative 2, 4, right? Okay? Well, we just said that this rotation here of 180 degrees is equivalent to an x-axis followed by a y-axis symmetry or reflection. Well, if I do both these things to a point, so I take 2, 4, and I put it over here, I reflect across the y, across the x, isn't it going to put it right there? What's the ordered pair there? Negative 2, negative 4, right? So I started with 2, 4, and if I do a 180 degree rotation, I'm going to get negative 2, negative 4, right? Do we see that 180 degree rotation around the origin is the same thing as an x-axis reflection followed by a y-axis reflection? It generates the same rule, right? Does everybody kind of see that? So my argument here, and this is why I want to bring this stuff up, because I think in some classes, when I was in school, those connections weren't made. When I was in school, we just went through this stuff and learned how to do this, and it was fine. Okay? But what I want you to understand is what we're doing here, we already did 2 years ago. Okay? It's just now we're doing it with functions. All right? Think about what these rules say. We'll address just the E right now because it's pretty much the easiest one to kind of show this visual with. But if I have, let's say our function is x squared. Okay? Think about the rule that says f of x equals f of negative x. When I say f of x, what does f of x represent? What does it mean?
Y value.
It's a y value. Okay? So this is a y value for a specific x. Does that make sense? What is this? F of negative x is just a y value, isn't it? That notation is I guess the question I'm asking. That notation that's a y value. Okay? Well, how does that x relate to this x? It's the opposite, right? Opposite of that specific x. Okay? Now, it might be a negative, but what if the x I start off with was negative? Then that would be a positive, right? Okay? So here's the question. We know This rule here should hold for 2, 4. And what that is saying is that when you take this x value and you now negate